Welcome, everybody. My name is Bryan Whitmarsh. You see CA Technologies, Idaho. You probably did not know that we had an office in Idaho. It's office of one, so I'm a flexible workplace employee. So I come down here a lot. We have a lot of our developers that are actually in the audience today. They're going to help me out today. But spend a lot of time here in Santa Clara. Excuse me. All right, just a quick agenda. The fun thing about today is I'm not selling anything. Yes, I do have a product manager title. I have a CS degree, but after 10 years in product management, I've kind of been dumbed down a little bit. So I have my developers to pull on, and I've done some extensive interviews with our developers. We have a big project here at CA that we are leveraging Elasticsearch along with some other open source technologies to build a powerful analytics engine. So I want to go through those components with you today. And then this is a learning session, right? I want to go through, I have like 11 slides that are fun slides that'll talk about some of our lessons learned. So you think you know it all when you start. Actually, I never think I know it all. But we've learned a lot of things as we've rolled in and been using the analytics engine based on Elastic in production. And so share some things, some tools, tips, tricks, and so on. I want it to be a fun conversation, discussion. I have a mic. I really would love to throw this. So if you have any questions, raise your hand or nod at me and I will throw it. If you nod off, that is also a sign for me to throw the mic at you. So appreciate that. A lot of you, we were at Elasticon. It was funny. We had a big booth, right? And this was the group of folks, scary group of folks here. But we had a booth, and people would come up to us and they're like, CA, like CA. Is that Computer Associates? Who is that? What do you guys do with Elastic, and why are you even here? So a lot of good questions came out of that. I normally just said, well, we're all about getting mainframe data to Elasticsearch so we can do queries. No, that's a joke. Funny? No. Okay. All right, what is elk? Now, you heard where I'm from, right? So the first time I heard elk, what do you think an Idaho boy thinks is elk, right? I heard this word like a bunch of times, and elk, what are they talking about? This is an Idaho elk, okay? So we love our elk. We have a lot of wildlife. It took me a little while. I found, the internet's a powerful tool, so you can look up elk when you're not in Idaho, and you can find out what elk is. Now, I assume everybody knows what elk is, but I don't want to assume because we know what that means. And so just a quick brief, what does elk stand for? Well, ELK stands for, the E stands for Elasticsearch, and that's where we're leveraging to store data, to store a lot of the information that we collect from our various products at CA. We store it in Elasticsearch. The L is Logstash right here, and that's a tool used for ingesting data into Elasticsearch. So you can take data, get it into Elasticsearch, and once you have data in there, it's nice to actually be able to visualize it and run reports and queries on it, and that's what the K is all about. So Kibana is that piece to be able to visualize that information. Now there's a bunch of other pieces, and I bet Ryan's going to go into some of these other details, correct, Ryan? Maybe show us some cool stuff around 6.0 and what's coming out? Ryan's nodding his head. Excellent. So these are the XPack is all these right here, open source, free. And then the XPack provides added value services on top of the open source technologies. And so here's some of the other paid type services that you can also add to your Elastic stack. Okay, being from Idaho, we have different kinds of farms. Anybody know what this is? Sturgeon. Anybody want to guess what the weight of this sturgeon is? 410 pounds. And this, we called her Big Mama. So this is my father-in-law's business. In Hagerman, Idaho, we have a bunch of spring water, so they raise trout and sturgeon. And the way I have to get my hands on things. Even though I'm a product manager, I still try to be technical, right? And so I always take what I learned back in the day building a fish program in Paradox 4.5 for DOS. Anybody use Paradox 4.5 for DOS? Thank you. Yes. So I developed, my last program was a PDOX 4.5 application, and it keeps track of all the feed and everything that goes into these fish. And gives them conversion rates. So I like to take that data and see how simple it is to get it into new platforms. And so first thing I did, knowing nothing about Elastic, downloaded, very simple to install on my Mac, and I got Elasticsearch up and running in Logstash. And then I had to figure out how to get PDocs 4 or 5 data into Elasticsearch. Luckily, comma delimiter is kind of a standard. So I was able to export, it was 20 years worth of fish data into using Logstash, comma delimiter, and get it into Elasticsearch, and learning how to run and visualize that information using Kibana. So that's always, I get my hands on it. I was impressed with how quick I was able to get some analytics out of it. But this is my experience with analytics. And like I said, we have our developers here that have the much more depth of knowledge. I've interviewed, gone through a bunch of interviews to get a bunch of information, but feel free to fire away at tough questions. Okay, here's our problem. I'm going to define our problem for us. I like this picture. Okay, you'll see some good pictures. You can laugh at them if you want. First of all, we have lots of data. We have products that collect customer experience data, they collect application data, they collect infrastructure data, and typically they all have their own data repositories and their own data stores. We want to be able to collect that data and correlate it into a central location. So you hear the buzzwords, data lake, data reservoir, whatever you want to call it. We wanted to get it correlated into a central repository. We needed to be able to, so first of all, support multiple products, multiple repositories, and then we wanted to provide a SaaS offering. We hear that's kind of cool these days. SaaS offering, and needed to support multi-tenancy. And then the power is running the analytics on this, being able to get insights out of this data that you're collecting. And so we wanted historical, real-time, these are all the buzzwords, right? Anomaly detection, predictive, prescriptive, advanced learning, and Skynet, right? Anybody know what Skynet is? This is the T500, Terminator. You watch Terminator, right? You've seen Terminator? This is the idea of machines taking over and machine learning, and I don't think we're there yet, right, Ryan? Not yet, okay. Anyways, and also one of the requirements was to initially keep it royalty-free from a distribution perspective. Okay, so we went out, developers did some research, because that's part of the R&D, is right, research and then development. We do it all the time, right? We always research first and then we develop. Okay, anyways, a best practice was to use a Lambda architecture when building this infrastructure. And of course, Idaho boy, what do I think Lambda is? This is a tougher one. Back in the 80s, a movie.
The nerds.
You are awesome. Lambda, Lambda, Lambda. Some of you have watched this, right? So I got somebody in the back row. Excellent. So it is not this Lambda, 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 although this is a cool fraternity, right? Lambda, 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 the nerds. What is Lambda architecture? Lambda architecture basically just describes the process of being able to take data and be able to put it in and analyze it in batch mode. So you can take data, put it in to a repository, and so you can run batch processing against it. It has a speed layer component. So as the data is streaming in, you can run jobs on it. You can get real-time streaming analytics. And then it has a service layer component so that you can run queries against it. All right? So it's not Lambda, 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 although that's funner. Now I'm going to get into a breakdown of what it looks like. And this was built up over months of research and testing and playing. And it's still being added to, as I hear from the developers. Initially, you think you can just start with a few different open source technologies and build a great analytics platform. And then you realize, oh, I had a missing piece. Or, oh, this piece doesn't work as well as I thought it would, so I need to get a different piece. So this is the complicated architecture I'm just going to go over with you. The green highlights the areas that I'm talking about. The first one is you have your applications and your components that are collecting data out here, and you need to get it into this analytics engine. So you need an API-based solution that allows you to ingest data into the solution. So you need to have your APIs, you need to be able to have open standards to be able to basically load the data into. We also need, we have some onboarding and pluggable data science components in here as well for machine learning and some of the advanced analytics piece. All right, so we know how to get data in. We need to get that data and we need to shove it on something really, really quick. And this was some discovery, some playing with it, prototyping it. But we found that using a Kafka bus was very, very efficient for us because you've got all these different products that are throwing data at you. The last thing you want to do is say, oh, wait a minute, I'm trying to index it, or let me do something with it before I accept it, right? So key for us was just to very quickly say, okay, thank you, blah, right? Blah. Not that we want to puke it up on the bus, but this is the magic bus, and this is what we're using to be able to take the data, throw it up, and we're using Kafka for this. Now, sometimes people get on the bus that you don't want on the bus, right? Sometimes bad people get on the bus, and you have to kind of kick them off. We have a component that's a verifier, so it quickly looks at the data that's coming on the bus, and it'll say, oh, yeah, I recognize you, or no, you're gonna mess things up. I'm gonna throw you off the bus. The other thing we found at that point was that if we used Avro encoding at this point, we could make a lot of these processes much more streamlined, much more efficient. So at this point, we get the JSON information, get on the bus really quickly, then we Avro encode it, verify it, Avro encode it, put it back on the bus. So we're using obviously multiple topics on the Kafka bus. And so each product has a number of different topics. So we get it, we verify it, and then we put it back on the bus, Avro encoded. Any questions yet? Really want to throw that mic. Yes. Can you catch? Can I throw?
Xinan Tang from Clear Cloud Global.
Uh-huh.
For the Kafka bus, I heard if the number of topics is more than 64, there is a performance issue. Have you ever met this problem?
If the number of
Topics.
Topics.
More than 64.
More than 64 topics. Now I know right now we're right about 30 topics, is that right? And do we expect to expand those? We plan to reduce it. That's good. Okay, so yeah, we're under the 64. Anybody in the room experienced that? You have over 20? You don't have any problems. Okay. About 64. Okay, magic number. It's the magic number. Okay, we haven't experienced that because we don't have that number yet, and we are trying to reduce our number of topics. All right, we got the data, we got it back on the bus, we got it on one of the 30 topics or 20 topics that we have. And then with Kafka, you have consumers and producers. And first thing we do is we're leveraging Hadoop for large store. So when you talk about being able to have batch processing, and the way I like to term this is petabytes of data. And when we get to Elasticsearch, it's more terabytes of data that we're talking. So we found it efficient for our historical data that we want to keep forever and ever and ever, that's going to be petabytes of data, that it's consumer, and it's bringing that data in raw format, and we're just storing it in HDFS. Okay? Now, at this point, you notice we have a couple numbers here. So 1 represents batch mode. We're leveraging Apache Spark, so folks can run Spark jobs against this layer to be able to run batch jobs, be able to get data out of this layer. Now Spark also has the ability to run, obviously, real-time processing as well. So we are leveraging this for real-time processing. It's a consumer of the Kafka bus, a consumer and producer. So if you have a job here, it's able to consume the Kafka information and then throw it and result it back onto the bus. And so yeah, down here you see, when you hear Apache Spark, it's more than just Spark, right? There's components like Spark SQL, which you would leverage to be able to do your batch processing on the Hadoop side. Streaming would be your real-time processing. MLib, so machine learning libraries to be able to do some machine learning jobs, and so on. And same thing over here. Hadoop has, HDFS is what we're leveraging from a Hadoop perspective. All right, questions? Make sense? All right, so we got 2 of the numbers. Now I want to highlight just some other pieces here. The first one is the data science. I talked a little bit about pluggable data science, and this is really the power, is to be able to provide this pluggable data science API with stuff like, okay, what is the information that you want to consume? What do you want to produce? Here's the job that I want you to run, and here's the schedule that I want you to run that job on. So CA has, we know certain types of data. Now, you can get a lot with generic machine learning, but when you combine that with the technology and the knowledge or understanding that we have in a particular space, say like application performance management, then you can get better insights, better machine learning, better data science out of the analytics engine. So we have this component, and we build kind of these little machine learning recipes, if you'll call them that. Okay. We talked about the scheduler. We're using open source again. This is a Quartz scheduler that we're leveraging, open source technologies. And then we found having a separate process to do a lot of the utility things. Like we'll talk later on about when your index gets too large, you need to re-index, you need to roll it over, you need to do those types of things. So having that as a separate process is good. Okay, now we move on to the service layer. And the service layer is where we're going to be able to run queries and get our insights, visualize the data, get the information out of the analytics engine. And so we chose Elasticsearch for this. Previously, we had another NoSQL database solution that we were using. I'll talk a little bit about that in the next few slides. But we found this to be very, very effective for what we want to do. And here, getting data into it, you notice that we're not using Logstash or one of the other provided tools. We just found that to be very efficient, to get it indexed very quickly, we're just using the index APIs, and we've wrote our own indexer to make it very, very efficient. I don't know why I'm holding this and talking to it since I have a rappel here. Somebody wants this. Any questions so I can throw this? There we go. You ready? Okay. Yes. I think I pulled my back.
So one is, how real time is it? Because one thing is the Spark streaming is again pushing data back to Kafka bus, and then you have an indexer. There is some kind of micro batching within Spark streaming itself, but that's not my question. But the thing is, you have to be getting data from a Kafka bus to make it almost real time.
Great. It's near real time. So what would we say would be, it depends on what job you're running, how big the job is, depending on how near real time it is, but yes.
Is it the second time response time, or is it minutes? When I say near real time.
Is it seconds or minutes? We would intend most of them to be near second times, but it depends. It varies greatly on what job you're running, right? If you're running a very complicated job at the speed layer, it's going to slow down. It's going to be minutes versus seconds. Is that vague enough of a product management answer? You're all looking at me like, oh, friggin' product manager. Is there a developer up here that knows the real answer? No, it varies depending on the speed. But yeah, you want it near real time so that you can get that information as quick as possible. All right, so we wrote our own indexer. You get to hold it now. You get to throw it to the next person, because I'll just hold it and talk into it like an idiot, okay? So here again, remember we talked petabytes of data here, terabytes of data here. And here we use a combination of hot nodes, warm nodes. I'll get into some detail there. But you want this information to be readily available, very quick to search, near real time when you run your search queries, very, very quick, okay? And then you need to have a API layer to be able to make the requests of the service layer. We're also leveraging Kibana for this. And it depends on your use case. You're not going to give a business person Kibana and say, hey, this is great information, here you go, because then they're going to click on one thing and say, What happened to all my data? It's missing. Oh, you put a filter up there. Oh, I didn't know I did that. So, so there's other tools that you want to leverage depending on the business user or the developer. You know, the data scientists, yeah, they would love to go in there and they can do all their manipulations. But if it's a business level person, you probably want to provide a abstraction layer at that point. And that's where you can use the APIs. All right, so point being, you know, it started off as kind of, oh, we'll just use a few open source technologies to create this great analytics engine. And then, oh, we need this, we need that. It becomes complicated. And we were at Elasticon. We did a birds of a feather session. And we had folks like Spotify and Salesforce. And they were at the same point. They're like, yeah, you know, we're running into issues. We're adding components. And you have to really scale that architecture out. So it's kind of the, do you want to do it yourself or do you want somebody to do it for you? But either way, you're going to need to build out, depending on the insights or the analytics you want. Okay, now I get into lessons learned. This is where you can take notes. Actually, you'll get this, so you don't need to take notes. You can just keep looking up and not surf the internet anymore. Okay, first thing that I got over and over from the developers from a response, and pain that I learned when I was using my little fish program, because I did it, I got it into Elasticsearch, then I tried to search on some string that was analyzed or not analyzed, and so I ended up deleting all the indexes and then deleting the template and then starting over and over. Yeah, I did that like 50 times. So planning is very, very important, okay? So make sure that you take time to plan, and don't try to reuse a schema. If you're going from one architecture to another, don't try to use an existing schema and just cram it into Elastic, okay? We might have made that mistake early on where we had another and it ended up having all these different indexes, and then you run into performance issues and scale issues. So really design it and plan out for leveraging Elastic. And then prototype. Test, test, test. So you may not think that changing your shard by 1 is going to make much of a difference. It can make a big difference. So make sure that you have time and you are prototyping. And spend money here that you're putting this at scale and you're testing it. My 2 Ps. Do you see my 2 Ps? I have cute little pictures. Nobody saw them. Thank you. 2 Ps in a pod. See, I'm getting some interaction. Any questions? We want to throw that mic again. Hey, you get to throw it backwards. Oh, okay. Hand off.
Can you talk a little detail about the schema from outer sources to Elasticsearch? What kind of measures that you made that made it easier for you?
What kind of message? Sorry.
You just mentioned about the schemas,
Yes.
incompatibility or performance.
Oh, yeah. So we were taking one schema. So we had an existing solution, and it had, you know, table definitions, and we tried to cram it into an Elasticsearch schema, and we ended up with all these little indexes and large indexes. And so it's best to plan and figure out, try to keep it as flat as you can. But that's where we ran into issues where we just, okay, it's easiest just to keep the same schema and move it over, you know, from table definition to index definition. Not a smart thing to do.
So was it a problem with the joins or?
You get into problems with being able to visualize the data. You run into performance issues when you need to correlate data from one index to another. You get into, especially we had to do a multi-tenant solution, and so then you're having to protect and make aliases for the indexes. So it got very, very complicated. So suggestion is just take the time and make sure that you plan and prototype it for Elastic and how it fits best in Elastic. And we can give you more details after. All right, shards. First time I heard about shards, I thought about Florida. These are the hanging chads. I don't know. Every time I heard that, some of you smiled. Florida election 2000, somebody? We won't talk politics. All right. So one shard does not fit most. I think the default when you create an index is 5 shards per index, okay? And for some indexes, that works. For others, we found that it didn't. And so tweaking that, and that's all about, it's kind of like this balance. Do you want really quick ingestion rates to get it into Elasticsearch very quickly? Or is it more important for you to be able to query and search the data very, very quickly? So there's kind of this balance, and you can play with these different things. For us, we found that with large indexes that we're keeping the shard size at about 5. For smaller indexes, we're keeping it at a low number like 1. All right? Rolling over is very important. So you don't want your shards to grow too much, and when they do, you need to make sure you're rolling them over. And you don't want your shards to get larger. I think the recommended size is don't let them get over 50 gigabytes, and we're rolling them over when they get close to 30. Okay. Know your nodes. Okay? Master node, client node, data node. Data node is very important for us at the service layer. We do a lot of time-sensitive data. So we collect data, time-sensitive data. And when we first get it into Elastic, the first 7 days is normally what people care about the most. So we want it very, very readily available, very quick. And so we put that in a hot node. It's what's called a hot node, hot data node. And it allows for very quick access. Now, you can't put too much data in there, so you restrict the data. I think we're at 2 gigabyte, what? 2 terabyte of data into the hot node. And then after 7 days, we age it and convert it into a warm node. And we do about 8 to 10 terabytes of data into the warm nodes. Still readily available, but just not as quick access, not as expensive. These are expensive nodes, but these, when you want those searches very quickly, they need to be warm. Client nodes, they do some work for you. They're mystery nodes, but they do some processing for optimization. Yeah, okay. Master nodes, they're the master. You don't have too many of these. I think we have 3 of them in our cluster. And then tribe nodes. When you have more than one cluster, tribe nodes help get data from various clusters. Okay? So know your nodes. That's important because not all these nodes are apparent. And for me, some of them are still not totally apparent. But the kid knows. I don't. Don't split your brains. You heard about this one? Okay. So this is an important one. This is just, when you start off and you have one master node, and you have primary and a replica, and hunky-dory, everything's great, and then for some reason you lose your connection, and master is hunky-dory, he still has his primary node. This guy's sad, right? He's like, well, where did my master go? And so he decides, because the default setting is number of nodes, he decides, oh, I'm going to promote myself. So, okay, cool. And so he's happy for a while. And then when they get back together, there's a line here that you can't see, but it's right on the screen. These guys get back together. Now you have 2 master nodes. That's a problem. Okay? So make sure that setting is half the number of nodes plus 1. Don't split your brains. Like my icon? That was cute. You have to be careful when you search some of these things on the internet, because some of the images you don't post. Okay. Avoid shooting yourself in the foot. I was very political with this one. This is just a shoe. There is no foot in this shoe. This person has shot themselves in the foot because they were a junior developer and they went out and they delete all index. I don't know what an index is. I don't need any of these. Delete all. Well, by default, you can shoot yourself in the foot. So set that value to true. Then there's a little bit of, should I be doing this, before you actually do it. Don't spend with disks. Probably obvious for most of us. But solid-state drives, highly recommended. Actually, really the only thing you should use, right? Solid-state drives. Avoid NAS and SANs. Avoid, no reason, when Elasticsearch is taking care of the replication for you, there's no reason to have RAID 5. Just use RAID 0 to speed up the process. And be careful with using EC2 data structure. Swapping can be bad. All right. This is in reference to memory. For Elasticsearch, you want to avoid memory swapping at all costs. So at the OS level, make sure that you are not allowing your OS to swap memory. Okay? You'll get all these, but if you want me in the picture, I understand. People are still awake. That's good. Monitoring is very, very important. And so use multiple types of monitoring. Don't just use one type of monitoring. We're using 5 or 6 different types of monitoring, and Bryan, right? Because Bryan logs in and what the heck's going on? But okay, I mean, it's always running smooth, no problems ever. But make sure you're monitoring log files. Make sure you, using some type of application performance, Java processing monitoring. You're doing some infrastructure monitoring in case you have infrastructure problems. If you're using Amazon, make sure you're using, Amazon monitoring. Synthetics are always good when Bryan's asleep. I don't test all the time, so Bryan can stay awake as a synthetic person, the T5000. He's taller. Elastic monitoring as well. So there's a lot of different tools. We highly recommend using them. Multi-tenancy without XPack can be a challenge. XPack provides some tools that helps with a security perspective and so on. Again, our requirement was initially to be not dependent on royalty bearing. So we did some things like color sizing the data. All the data is coming in. We stamp it with things like tenant ID, elastic tenant ID, and make it an alias. We need to be able to control access to Elasticsearch because you want to make sure that somebody doesn't get somebody else's data. That would be bad. People don't like that. We have had challenges with Kibana coming into some resourcing issues. And so we have put some guardrails around Kibana because right now we're letting our customers, SaaS customers, come in and run their own queries in Kibana. And we found that if you don't limit them, they'll do things like, split it here, split it here, split it here, split it here. And eventually, they can run your system out of memory, or your node out of memory, which is a bad thing. So we have done a couple things, like we have a custom plugin that limits the number of level of aggregations that people can do, so that helps. And also, there's a setting here, this setting right here. By default, it's 70% of the heap size. We found that it's a little safer if we lower that. In fact, I think we lowered it down to 20% to prevent from causing problems with our node. Ingestion spikes, bad. This is one of the tips that came from lessons learned, is that we were experiencing particular nodes at particular times, that during very high ingestion levels, that we would run into where the node just would reject it. It would say, nope, I'm too busy, can't talk to you now. Developers tell me that all the time, but sometimes Elasticsearch tells us that as well. And so we did things where we could increase. There's actually this thread pool where we can increase it from 50 to 500. We can also add some sleeps. If we start Elastic nodes saying, hey, I'm too busy, leave me alone, sometimes you want to be patient with that person and then wait for a little while and then go again. Or sometimes maybe you just have a different issue that you haven't discovered yet. Yes?
Doesn't it increase latency? Increasing query size, does it increase latency?
Does it increase latency? Yeah, I mean, you could be making the problem worse, right? By cranking this up to 50 and then you get more people in the queue and it's just slower. But what we were looking at is just for certain bursts, the queue would get 60, 70, and we would get lots of rejections, so just for certain bursts. Now, if you're running at 500 all the time, you got a problem, okay? That's probably why the default setting is 50. Okay, last couple here. Limit your dynamic fields of play. Get the little catchy terms. There's a 1,000 field limit in Elastic for a reason, so probably be conscious of it. In a multi-tenant SaaS environment, at first we were allowing customers to create custom or dynamic fields. And so you needed to be careful there, because you could have 5 customers create 50 additional dynamic fields, and all of a sudden it's like 5,000, right? No, that's like 500. 5 customers create 100 fields, it's 500. Crazy math. So you need to be careful, so make sure you normalize this and have checks and balances to make sure that you have certain areas for custom fields and you're not allowing dynamic fields to be created. Yes, question?
So did you consider creating separate indexes for each customer, or was it too many indexes, as opposed to throwing away one index?
Yeah, I mean, I know that conversation happened, but I know we stuck with not doing that. Why did we not do that, Vinky?
Yeah, my question is, why did you start versus a?
It would just would have been too many indexes, right? Too many indexes. Yeah. And yeah, on the indexing topic, we also we went through kind of a flattening of our indexes. We found that we had too many. We flattened them out. We're providing Kibana with one index, which has been provided a lot better performance versus, and it's helped the customer experience, right? Instead of them having to guess which index they want to find their data in, you have a flattened index. So I highly recommend that. Yep.
Can you elaborate on what is a dynamic field?
What is a dynamic field? That's just the ability for a customer to create their own field. So we have the ability for a customer to say, okay, your mobile application monitoring collects CPU and user input and all this, but we've got cart status that we want to collect as well. So we would allow them to create a custom event that says, I want to capture this value in the mobile application, and then we would dynamically create another field inside of the Elastic Index. Make sense? Ah.
That's the ES future, right?
That's ES of the future?
Yeah. It's allowed.
It's allowed?
Yeah. And also supported very well. I don't see why there is a problem.
Well, don't you run into the 1,000 index problem? You don't want to have an index that has tons of fields, right? Because your performance is going to go to bad.
But that's a design issue, right?
That's a design issue. Okay, let's talk about that after. That would be a good topic, and maybe Ryan will enlighten us. He's smiling. He's like, that guy knows.
And more, my question is, if you support a user to create a dynamic
Correct.
field,
Huh?
do you use a dynamic template?
Do we use a dynamic template?
Yes.
I thought we just used static templates. No,
That's a bad. That's very bad.
that's very bad. Okay, we'll talk about that after. You can. That's why we're here, right?
That's the people. They know much more about this.
That's why we're all here. We're meeting up. You're going to give us some information.
Yes.
I'm just a product manager.
No, you know much
Two
more.
peas in a pod, you and I. Okay. Again, just reiterating, take time to plan and prototype. Yes?
Just one more question around your flattening of your indexes. Did you deal with sparse data at that stage when you flattened the index out? So not all the fields having data in them?
How do we deal with not all?
Sparse data?
Sparse data. So a lot of fields that don't have anything in them just because it's one index.
Okay, so in our use case at least, I hope I'm audible at least. So flattened out, it's being handled in a slightly different way actually. So it's a kind of approach where we, at least in our use case specific to our application, we hold data for 30 days and after 30 days we just delete the data. So we didn't actually, as in worth the time to spend where you go entirely, migrate from or re-index the data. So we handle it our application layer, we actually send data to the both sides. So the application actually handles what was to the flattened out index and the old side. So at least in our use case, that fitted our purpose.
So it's not a big deal for us because after 30 days we throw it away anyway. So if we have some fields that don't have data in, it's not a big deal for us.
Not to have sparse data, just back the end, taking a lot of memory.
Take a memory.
Yeah.
Yep.
Sure. So sparse data didn't matter.
Okay. Yeah, it didn't matter to us. Memory's cheap, right? Just making that up. Okay. And then I promised I won't have any sales slides, but CA Technologies, why pick us? Because we have cool t-shirts and we have yo-yos. Now, this is Vicky right before she threw it on the ground and it fell apart and smashed. So be careful with those yo-yos. Could be a choking hazard. Could be dangerous. But yeah, this is just what we do. So we have this analytics engine. We take application data, infrastructure data, network data. We put it into analytics engine. Because of the power of the open source technology such as Elasticsearch, we can gain awesome insights out of it. So I satisfied I would say something. And yeah, if you want to try this out, we got a free 30-day trial, and you can go straight into Data Studio. You can play around with Kibana. You can tool a mobile application. You can tool a web application, and see and play around with it. And we'll have a hosted image for you for free. All right, you guys have been asking questions. It was awesome. Do we have time for more questions, or should we cut it? Two questions.
The slides will be online, right? The slides.
Slides are all online. Yep, you'll get the slides. That was an easy. I can't answer that
What's
one.
in your data science manager? What is that?
What's in our data science manager?
Yeah.
So we have the ability for a structure for folks to create like Spark jobs to create, and then it gets posted, and then we have a manager that runs at the right time and scheduler and all that kind of stuff. Sorry, I was only allowed 2 questions, and the next one's going to be tough. So that wasn't a question. What's your question?
Yeah, okay, so I sort of didn't understand what was being indexed, but it seems like that the like entire product is like based off like Elasticsearch. Is that it? Is that right?
No. So
okay, it's not.
no. Well, I'll explain my product more after, but I promised I wouldn't spend much time. I just wanted to show the analytics technology and talk about how we're using some open source technology.
Oh, okay, so wait, it's not for like. Okay, never mind. Go ahead.
Laughing at me. We'll talk later. Thanks. All right. Hey. The marketing gal in the back that broke her slinky. There we go. Okay. Thank you. Did you want me to say anything else? Are you going to write it on the board? Okay, perfect. All right, I'm excited to hear what Ryan has to say.
So my name is Ryan. I work on core Elasticsearch. Can't hear me. Let's see if I can adjust this. Can you hear me any better?
Yeah.
Is that any better? No? Yes? Okay. Okay, so I work on core Elasticsearch. So this is like the Elasticsearch team. I work on low-level bits. I'm an Apache Lucene committer. I'm also on the project management committee for Lucene. So I do all low-level stuff. If you have questions at the end about Kibana or Logstash or anything, there's someone here that might be able to answer your questions, but I pretty much know Elasticsearch. So, and that's actually what I'm going to talk about specifically is Elasticsearch and the upgrade experience to 6.0. So we've been preparing this big major release 6.0, and the upgrade experience is one of the major things that we've been working on to make it easier to upgrade. And so that's kind of what I want to talk about. So. First, we'll talk a little bit about how to prepare for a major upgrade, because there can be a lot of things that you need to check when you're doing so. We'll talk about some of the things that we've done in 6.0 to make upgrades easier for actually accomplishing the upgrade. A couple major things that change in 6.0. So major releases are a time to make breaking changes, and so those breaking changes is what you need to be aware of. And then finally, just a little note at the end about our Pioneer program, how you can get something if you help us find bugs in the new version. So when we are preparing to upgrade, first thing you want to do is read the docs. So we have documentation listing out all of our breaking changes for each release. You can see here, these are our first pre-release, so Alpha 1, Alpha 2, and we just released Beta 1 a couple weeks ago. So we have blog posts for each of those. When we finally release 6.0 GA, we'll have a big blog post that'll cover everything all together or something like that. And then these breaking changes for 6.0, these are kind of updated as we add more into the 6.0 GA. So the breaking changes especially are important to read. We kind of cover some of those breaking changes in each blog post. So that's the first place you want to start. Now, these breaking changes you want to be aware of when you're using something that is going to break in the new version. And so since Elasticsearch 2.x, we added this thing called a deprecation log. So this sits along next to your regular Elasticsearch log. It has log messages every time you use a deprecated feature. For example, in Elasticsearch, 6.0 underscore all is going away, and we just found out today there's not a deprecation log for it. So we're adding that so that if you try to use underscore all, you'll get a deprecation log message. There are duplicates in this log because it's just every time you use it. So every time something in Elasticsearch looks up that setting, it's going to log that. So it's kind of verbose. but it does cover most things. What it doesn't cover is like query time or some query time things. So if you use some deprecated feature in a query, it's a little bit harder. We don't want to be that verbose. If you have 1 million queries a day, then that's going to be a little too much. So there are still things that you need to look out for in the docs, and just know that you're using that feature. With 6.0, we are, or for the upgrade for 6.0, we also have now a UI for helping with this. So back in 1.x and 2.x, doing the upgrade to 2.0 and 5.0, we had a migration assistant, but it was kind of like, it was simpler than this. So this is actually part of XPack Basic. So it's now something you just install XPack, and you get this UI that will kind of guide you through the migration, all the things that you need to watch out for. So this UI will be in 5.6 so that you can first upgrade to 5.6 and then be prepared for the 6.0 upgrade. So then, once we're now ready to upgrade, what are some of the things that we've been doing? So upgrading to 2.x, this was pretty painful. There were a lot of major big breaking changes. 5.x was better, but we still required a full cluster restart, which was the big thing. So now in 6.x, we're no longer going to require a full cluster restart. So you'll be able to upgrade directly, rolling upgrade from 5.6 to 6.0. So this is good and all, but there are a lot of other things outside of just core Elasticsearch, data nodes and stuff. So what we'll talk about here is the Java client, the tribe nodes, which I know were mentioned earlier, and then kind of continuously indexing while you're upgrading the problems that can happen there. So the Java client, right now, prior to 5.0, we have always had this transport client is what we called it. So all the other language clients that we have, Python and Groovy and JavaScript and such, these are all REST clients. These talk over the HTTP layer to Elasticsearch. In Java, however, we've always used the transport client, which is a client that your application is essentially talking over the wire protocol, the transport protocol. But this means that it has to be exactly compatible with the wire protocol that node knows how to communicate with. This becomes problematic when we're trying to talk across a lot of different versions. So in 5.0, we added a REST client, a low-level REST client. So this is just similar to the other API or other language clients, that it talks over HTTP. It doesn't know anything about the particular APIs. All it knows is, hey, I can talk HTTP to Elasticsearch. It has some basic settings for how to connect to Elasticsearch, provides you some helpers there, but you still have to provide the API, and you have to serialize the JSON and all that. In 6.0, we're adding the high-level REST client. So this is basically just like the transport client. It has all the request and response and helper objects for every single API that Elasticsearch supports. So the nice thing here is that it is compatible across major versions, so that you can use it, for example, to talk to an older Elasticsearch node, 6.0 to 5.0 kind of thing. The one caveat is that it still does depend on Elasticsearch core. So if you've used the transport client, it sucks in a lot of extra dependencies. This can suck if you, for example, have one of those dependencies in your own application, and now you have version conflicts, and you get jar hell. So that's the way it is for now. The plans in the future are to get rid of all that from the high-level REST client. But this was the easiest way to kind of add it in, and it's at least no worse than the transport client. So next is the tribe node. Tribe nodes are very problematic because they are both a node in your cluster and they're a node in all the other clusters that they're communicating with. And so this means that they have to be on the same version as all of those other clusters, which means if you have multiple clusters, all those clusters must be on the exact same version, and there's no real upgrade or clean upgrade path there. So in 5.x, we added something called cross-cluster search, and this is the future replacement for tribe nodes. So tribe nodes will be going away probably in 7.0. They'll likely be deprecated maybe in 6.0, 6.1, something like that. So cross-cluster search, how does it actually work? Imagine we have two different clusters here. So we have a sales cluster and a R&D cluster. Any node can perform cross-cluster search. So cross-cluster search is really just the ability to know how to locate another cluster, and then it can do the same distributed search, just like when you ask Elasticsearch to search over a 50-shard index or whatever. It just has to know how to locate where those shards exist and do the merge across those shards. So with cross-cluster search, we can either use our existing cluster, or we can have a dedicated cluster. So in this example, we'll have a dedicated cluster here that's its only purpose is to do cross-cluster search. And then we add these settings so that it knows how to find these other clusters, so a sales cluster and an R&D cluster. The big difference between tribe here and cross-cluster search is cross-cluster search is not joining those nodes. So this optional dedicated cluster in the middle, it does not join the other clusters. It has no knowledge of its cluster state. All it's going to do is ask for the information that it needs ahead of time. So go and ask, hey, what shards, where are these shards, so that it can go do the multi-shard search. So you can configure Kibana to talk to the cross-cluster cluster, and then it would then spread out. Kibana, you can tell it to create indices directly, but then it's the thing that will actually talk to the other clusters. So these are lightweight connections, not heavyweight joining nodes like we have with tribe node. The syntax for how you can kind of control which clusters you want to actually search in. So essentially, you just use that name that we configured as a prefix for the indexes. So even if you had two indexes that are named the same in your two different clusters, you can uniquely identify them by their cluster name in the cross-cluster configuration. And then when there are many, many, many shards, to do cross-cluster search is efficient in how it will actually reduce the search. So say we have 256 shards that we need to search over. We'll do them in batches. So we'll do, say, 128 and 128, reduce them down, and then merge those results, so like two-phase. OK, so the final thing or one of the final big things that we've been working on to make upgrading easier, and this isn't just for rolling upgrades, this is for all upgrades, is making replication more efficient. So for as long as I've worked at Elastic, which has been over 3 years, we've been talking about this feature called sequence numbers. Now, the idea of sequence numbers is instead of doing segment-based replication, which is what we currently do, we keep track of each individual operation, uniquely identify that operation, so that if something happens, we can replay only those operations that are necessary on a shard that is missing those operations. So instead of having to, say, copy a gigantic 5 gigabyte segment over, we can copy 3 operations, which are the only difference between those. Now, normally, this is difficult to distinguish. So here we have our primary and a replica. Request comes into the primary writes it locally, and then forwards on the request to the replica. You can see that both of these have 3 different segments, but they're kind of different sizes because merges and stuff happen on each replica independently. So they can happen at any time. They're in the background. And so the kind of hierarchy of where documents exist in a particular segment is completely to do with the randomness of each shard or each replica. So in the current segment-based replication, if this goes out, and we've had this background merge going on to segment 3 here, now we have a new segment. Well, we can't just copy over some data. We have to copy over this entire segment too. Now we have to get them so that they're exactly the same, because that's all we know is these are the segments. And so we have to get the segments to be exactly the same. With operation-based replication that we're doing with sequence numbers, the idea is to keep track of each operation individually. So here we have these segments, but then we also have, say, 3 operations that have happened on top of them. We replicate it. Okay, operation 4 has been acknowledged back to the user, and this original primary goes away. This is upgraded to the primary. We finish our background merge, right? So we have different segments now than the other node does. This other node comes back online, so it was just temporarily unavailable over the network. But we don't have to do anything because we actually still have the exact same operations, even though they have different segments. So this makes recoveries much, much faster. This is really important for upgrades, especially when you're doing rolling upgrades, because nodes are always going to go offline, right? You take a node offline to upgrade the version, start it back up. Now the question is, do you have to copy gigabytes of data because there's still indexing going on, or do you only have to apply, say, a handful or hundreds of operations across the wire? So this is just a little kind of diagram of how sequence numbers work internally. They kind of have these local checkpoints and global checkpoints. So each replica first keeps its own local checkpoint. The primary keeps track of this global checkpoint and kind of tells the replicas based on each replica sending back information when it can upgrade. So you can see the global checkpoint will jump here in a minute when each replica, or the other 2 replicas finally acknowledge, like, oh yeah, I'm up to that point. One of the things I think I mentioned on one of the earlier slides for this, this is kind of the future of a lot of more advanced features. This is the building block that we're going to use for cross data center replication, which has been a very much asked for feature, as well as changes API, so that you can see what's the difference, what changes have been made since this time to Elasticsearch, or to an Elasticsearch index. Okay, so that's running the upgrade, but your application may still be using features that either are going to disappear or maybe they're going to be deprecated or something like that. So there are a bunch of things that you need to be aware of. I'm not going to talk about all of them. I'm just going to talk about a couple big ones. There are a lot more changes. There are also a lot more great enhancements, speed improvements and stuff like that that are in our blog posts and everything. But here, type removal. So I'm sure all of you are aware of what types are. When you index into Elasticsearch, not only do you give it a unique ID, but you also give it a type. And people have always thought about types as database tables. And this is really, really bad because they're not database tables. They're not independent. They're all part of the same index. And by using multiple types, you lead to sparse data within your index. And so Lucene has historically not dealt with sparse data very well. And so your index can blow up when you have very different data that you're storing all in the same index, but in different types. So we made the decision a while ago to finally get rid of types. But it's a very delicate and difficult process because types are tightly ingrained in everything about the Elasticsearch APIs. So in 6.0, you'll no longer be able to create an index with more than one type. If you use parent-child, there's already a feature that will replace that called the join field, so you can look that up. In 7.0, all of the APIs that take type, the type will become optional. So in 6.0, you'll have to use a single type. You still give that one type doc or whatever. In 7.0, you'll be able to change all of your clients to use the URLs that do not contain type, but types will still exist in the background. It'll just still be a single type. And then finally in 8.0, types will be eradicated. So long-term process. Another big one that I kind of mentioned earlier is _all. So this is a catch-all field that's been around in Elasticsearch for a while. It's kind of surprising to some people because by default, any field that you create, it gets duplicated into this _all field. So you're actually using a lot more index space than you realize, and it also doesn't work very efficiently, say, with numbers and stuff, because it's just text. That's all it knows how to handle. So we made some improvements to how the query string and simple query string queries work, and so now what you would do is just use the fields parameter for those. So you could before, but it's improved in kind of the relevancy of how those queries are built. You can specify a list of all the fields that you want to include in your search. And it supports wildcards and stuff like that for the field name. If you do want to have kind of this catch-all field that was just like _all, you can still do that. You just do it yourself with a copy to. So you can go through and add a copy to declaration for your mappings to whatever your all, call it my all or whatever. We will have back compat in 6.0. So if you have an index and you're using _all, it will still upgrade to 6.0. You'll still be able to use _all. It'll just go away in the future. You'll have to reindex it at some point before 7.0. A couple other things. Obviously, indexes created in 2.x or before. So that would be on older Lucene versions. Lucene only supports one major version compatibility. So therefore, Elasticsearch only supports one major version compatibility. So for anything like that, you would have to reindex to get data directly from, say, a 2.x or 1.x cluster into 6.0. Can't really see it. It's kind of lined out, but Boolean settings in Elasticsearch, they used to be very, very lenient in, they would support true, false, on, off, yes, no, 1, 0, and now it's just true, false. So there's deprecation warnings for this in since 5.1 or something like that. 32-bit JVMs, we've gotten rid of the support for those. So upgrade to 64-bit JVMs. Content type detection, this has gone away. So if you're using curl, you have to specify the content type, application/JSON. And then scripting. So in 5.0, we added Painless, our fast and secure scripting engine. We deprecated all of these other script engines, and so in 6.0 they are removed. And so finally, like I mentioned at the beginning, if you go and download Elasticsearch, the beta, we'll have a second beta coming up in a few weeks. Download this, try it out, find any bug, we'll mark it and get some free swag or something like that. So, any questions? Yes?
The all field?
Yeah.
That's like a catch-all field for saying
Yeah.
everything is dumped into it. So
Correct.
if I'm doing a cross-field query, I basically default going to the all, unbeknownst to me.
Right. So if you use the query string query, by default it'll go to _all in the existing versions of Elasticsearch.
Layman like myself who like builds their Elastic basically I have a duplication of all my data in the all space and
Exactly.
cells.
Right. If you want to still search over all of those, you can simply say fields star. So you can still search over all fields if that's what you really want, but you'll get a little bit better behavior with that because we're a little more cognizant of, oh, this is a numeric field, so this is how we're going to parse it. We're not going to try to do a text search on a numeric field.
So everything goes in all is actually analyzed?
Right. Right now, it's analyzed. It's with the default standard analyzer. It's not great relevance. Yeah. Sorry, do we have that microphone? It's hard to hear up here.
Where is it?
So the sequence ID based replication you're talking about, does that leverage in any shape or form the translog, or is that totally separate?
So yes and no. Some information about the sequence IDs are stored in the translog, but the translog is still something that has kind of nothing to do with sequence numbers. Translog has been around since long before sequence numbers. It's just a place where operations that have not been committed to Lucene yet are kept. With sequence numbers, we're keeping track of these things even after they've been committed, and in a future release, we'll be able to actually roll back some of those Lucene commits if we need to replay from a certain point in time.
Thank you.
Yeah. Sorry, what?
Like a buffer or anything. It's just all written right away.
The translog or the sequence numbers?
ID.
Sequence numbers are information that is attached to the document kind of within the Lucene indexing buffer. So it's just like some meta information, this ID for this operation of an add or a delete or whatever.
You mentioned you are going to get rid of Griffey script language.
Yes.
However, the concurrent status of the penless scripting language is not good enough. For example, we cannot even do string splitting with the penless. So it's far from working language yet. It's a lack of a lot of Java 9 features.
A lot of Java 9
features?
Yeah.
Even though your guys claim it's 100% compatible, but in practice we tried and it failed. So we have to using the Groovy scripting language.
Okay, so there's definitely string splitting in there.
I tried 5.4 and didn't work yet.
Okay, well, I can talk to you more about it afterwards. But as far as Java 9 features, I mean, there's no syntactic changes for Java 9. There are efficiencies that we're using in the compilation of Painless in the backend that are Java 9 compatible. So that's all we mean by Java 9 compatible, is that it will run on Java 9 when Java 9 is released. And we test that right now.
Yeah, the ideal case is we can try the script either in the Java 9 or Java 8, then it automatically run on the penless environment. However, in reality, it doesn't work that way. So it gives us a lot of problems. It's really painful. It's not penless. That's my comment.
Okay.
Okay.
I'm happy to talk about it more.
We really want to try that, yes.
Okay.
So right now, I think the expression scripting is very good. Yeah. However, the penless is not good.
Okay. Question over there, maybe? No? Somewhere? Okay. Cool. Well, thank you very much.
Sorry. Hello? So, question about upgrades. So, I haven't done any upgrades really other than just drop-in replacement of Elasticsearch itself. So, but given what you're talking about with 5.6 to 6.0 having the backwards compatibility, so you have a UI. Is there, I imagine, is there some script level support if I had to automate it across a cluster, but without UI, a headless type of thing?
Script level ports?
Script level support to automate upgrading, a rolling upgrade. So,
I mean, you can write scripts.
well, you have a UI, so.
Yeah, so that's part of XPack Basic. So there is an API that's added in XPack Basic to kind of get all the information that the UI is grabbing for the things to be aware of with the upgrade.
Okay, so it's just a, by the way, here's what you need to watch out for an upgrade. It's not really a,
right, so it's a new
it's
new
not an
endpoint.
upgrade UI.
Well, so it's there's a new endpoint in XPack that comes with the basic, or it's part of the basic license. So it's free, you can use it whenever, and it does a scan of all of your settings and index settings and everything within your cluster. And will kind of return to you all of these things to be aware of, along with some information like, hey, this is like really serious, you have to change this before upgrading, or hey, this is just, you know, a good thing to know in the future, you're gonna have to change this because it's going to be deprecated in 6.0, stuff like that.
What about the time frame for a 6.0 release? When is that slated?
So we don't give exact time frames, but expect before the end of the year. Okay, thanks a lot.